Jill, I'm going to first go over how to figure this out with inscribed angles. I will show you guys with the second example how to do it with the formula. Because my last class, I want to show you both ends of it, right? So first, I'm going to use a different color. The first one's going to be, how do we handle the situation we have two secants that make some arcs? So I'm going to draw some lines here. So draw this for me, please. So draw that guy and that one. Yeah, same colors. Guys follow? Okay. Can you guys see how what I just created, how this is an inscribed angle to this arc? Oh. Really? Okay. Right? So this angle that I just made is inscribed to this arc. So if this arc is measured as B, what would be the measure of this angle? Half of B. Okay. Now can you guys also see how this angle is inscribed to what arc? A. So what's the measure of this angle? Half of A. At this point, now I'm going to redraw this for you guys for clarity. What I have now is I have this triangle here. Okay, and I have this is X. This is half of B. Then I have this guy. Okay, can you see that from that picture? I drew that out. I'm looking at this. Yeah, I'm looking at this triangle right here. Oh. Can you see that? Yes? Yes. Okay. Yes. This is an exterior angle to this triangle. So if I use that theorem, then I can say at this point that this angle, 1/2 of A, equals to the sum of these two angles. Yeah. Now this is in general terms, so this is a little more abstract than with numbers. Can you guys solve that for X? Andy, how would you solve this for X? How would you move this term to the left? Just actually move the whole term first. A positive 1/2 X. Correct? 1/2 X? Camera shot.
That's not true. I did not know.
So that goes away, right? So I'm left with 1/2 A minus 1/2 B equals to X. I know it looks weird because it's just variables, but we're just moving things around. Okay. Lastly, can I take out a half from these two? Yeah. So what I end up with here, I'm a little messy here, so I apologize. I'll put it over here. If I take out a half, I'm left with 1/2. Okay. So once we get this more, the formula is there for you. It's a tool, right? But I want you to know where the tool comes from and how we, how to make it better, how to see it better. So with that being said, let's try. Actually, take a minute. No. Just at least draw your lines and try to fill in some blanks. Take a minute. Good, bad, or ugly. Try this one. Here, in fact, Gio, my Gio card, Gio. Gio, do you see how this angle here is inscribed to which arc? This angle.
With 82?
Right. So it crosses this arc here. So then, what would this measure be?
41.
Okay, good. Now, at this point, this is tricky because you have to kind of fill in blanks on your own. But do you see how these angles are a linear pair? These two. So what would this angle be here? So 180 minus 41. 139. So this is 139, okay? Once I have that figured out, can I find this angle here?
Yeah.
So like, I'm going to redraw it for you guys. So I'm going to put it in order so you see it better. So if I take this triangle and I redraw it, I have 28, 139. Can I find that? Yep. Find it for me. Anybody? 13. But this is an inscribed angle that intercepts X. So what's X going to be? Split it up. 26.
Yeah, the formula was much easier.
I agree with you guys. The formula they're shortcuts. They're easier. But guys, if I give you a formula that's all you know, It's magic, magic, magic. Answer comes out. How does that help you guys out?
I just subtracted 41 from 28.
Yes, that's exterior angle theorem. Yes. So I'm not going to do that yet because I didn't stress that as much during class. What he's saying is this. Isn't this an exterior angle to this triangle?
Yeah.
So shouldn't this equal to these two added together?
Oh, I see.
So faster, 41 minus 28 is 13. Right. Again, I'm going to play the triangle sum theorem because I did that more with you guys. All right. This one. I'm going to go a little faster on this one just in case, just because it's a time. In this case, I'm going to draw these lines. So follow, this is the second note. Okay, draw those. Can you guys see how, in this case, this angle basically crosses this arc?
Yeah.
So what would this measure be? If this arc is B. Yesterday, I have a tangent and a chord. Yesterday.
I know. Oh yeah.
I was gonna pretend we know. Just repeat that. I don't know what they are now. Oh, it's gonna be half.
If that's 100, what's this?
50.
50. If this is B, what's this? Half of B. Okay. Also, I have this guy. This angle is inscribed and intercepts this arc. So what would this be? This is A. Half of A. And guys, for a second time, if I look at this picture, if I look at this orange triangle, I have an exterior angle, right? Equal to the sum of the two non-adjacent interior angles. So I could say 1/2 A equals 1/2 B plus X. Does that look familiar to you guys? Familiar?
It looks like
Exact same thing. So when I solve this one, I get the exact same result. Okay, so the nice part about this lesson is once you use the formula, it's the same formula. Formula. Okay. Okay. Let's try one more, guys. Actually, let's try this. I'm just curious. Do you guys think you're formula experts?
Well,
I'll give you guys a minute, maybe a minute and a half. Solve this with the formula. Try it. Go. Yourself. Subtract. What do you get?
72.
72, and then half of 72
36.
is 36. Okay. It's the exact same formula for both, guys. Right. Now, let's take a step back here. Let's try D just on our own here. So let's make our arcs here. So let's make this. Okay, so we're going to add those lines. We make some interchange angles that we fill in. Come on, the goal is that can I see it? Can I see the interchange angles? In all the chaos and the different things there, can I see it? Right?
I don't use the triangle in this one.
Wait, we're doing D, right?
Yeah.
Oh, I see it now.
Ready? Ready? Here we go. Ready? Ready?
what?
No, I wish. Inscribed, right? Or is that good?
Subscript.
Tangent and a chord?
Yeah.
So if this is 180, what would this be? 90. Yeah. Now, what would make this, what would this be then? This angle? 90. Now obviously it's 10, yeah, so I have that. I know it's not drawn to scale, guys, so I know this would be diameter, but it's not. It looks a little bit off. That's, let's go with that. At this point, do you see how I have this triangle? So I'll put an orange again. I have this triangle here, here, and there. Can I find that?
Yeah.
How?
Add 90.
90 plus 38, so triangle sum, that's going to be 128. So 180 minus 128 is 52. So this is 52. But this is an infinite angle that intercepts that arc with x.
104.
104. Okay? So the goal today is, can we try to see intercept angles within these circles? Is there a shortcut? Yes. But if I only know that, is that really helpful?
No.
Not really. You can get an answer out, it's right, but what does it mean? I don't know. Some number,
Passing.
Just
passing, right? My career, my life.
hopes and dreams.
Hopes and dreams. No, those go away. Go away. Those should be teach. I'm just kidding, I know. Okay, last one. Alright guys, tangent and tangent. So in this case, I have two tangent lines. How do I work with this guy? This one I think is easier. Because tangents, we know about those guys a little bit. In this case, I'm going to actually draw the center of my circle.
It's the equidistant one.
Okay? And I'm actually going to draw this segment here. What do you call that segment if it's from the edge of the circle to the center? Radius, right? In fact, I'm going to draw two of them. I'm going to draw one to each tangent, to the point of tangency. If I add these lines in myself, what do I know about a tangent line and a radius if they share the point of tangency? They cross at a right angle. So these are automatically right angles. Right? Secondly, in this drawing, the way I drew the lines, I added in my own lines. Is this called inscribed or central?
Central.
And what do you know about central angles to the arc intercepts? They're the exact same. So this will be B also. Okay? So in this situation, the way to solve for my unknown is I now have a quadrilateral here. I have a four-sided figure. I can add together x plus 90 plus b plus 90 equals to 360. Okay. I only have one unknown here. If I can do that. Watch. Ready? And we're done. Okay. So in this case, I'm going to go ahead and do my center. Okay. I'm going to draw my radii. So here's one.
How do you even spell that?
Radii. Oh, that? I'm sorry. THAT. That's right. That's right. Okay, so I draw my two radiuses.
I'll rock right to that.
Okay. So if I do that, what's this angle going to be?
Right angle.
Right? What's this?
90.
Right. And then what's the center angle going to be?
X.
X. So at that instance, then I can just look at the quad here that I have. And can I just say that 90 plus 45 plus 90 plus x equals to 360. So I'll split above here. So x plus 225 equals 360. X is 1. That one's easier. Yes? No. So what is the goal today? The goal today is this. We have three different scenarios of angles that are created through either secants, tangents, or those two guys with different combinations. There's a shortcut, a formula. But what we want to work on is, can we create our own intercept angles and fill in our own blanks to actually understand where it comes from, not just magically put into this formula. Answer comes out, and what does that mean? Right? So the goal is, can I see? That's the goal. Can I see?
Can you see it?
You have 5 fingers, or 4 and a thumb.
That was 3 and a pinky.